Alright, so finishing up the notes. We're now going to use the unit circle to find some values, some trig functions. So this says find the exact value of each expression. If undefined, write undefined. The sign of pi over 4. You are probably going to need to have your unit circle out side by side if you haven't learned it yet. Okay? So the sign of pi over 4. Sign is what coordinate? Sign is y. From the before we went over the unit circle. So sine's y. So basically, wherever pi over 4 is, you're looking for the y coordinate of pi over 4. What's the y coordinate of pi over 4? So that is your answer. That is the exact value of sine pi over 4. It is the y coordinate of pi over 4. Okay? Let's look at B. The cosine of 135 degrees. Cosine is what? X. So you're looking, what is the x coordinate of 135 degrees? Simple enough, right? Now you can use your unit circle to basically, answer these things, but the thing is you're not always going to have this piece of paper there and you need to commit this to memory. You got to be able to know that, okay, so cosine of 135 degrees, that's the x coordinate. 135 degrees is in your second quadrant. Bam. Okay? You got to mentally see. Like when you close your eyes, you got to be able to see the unit circle there in your head. Okay, I see it every time I blink my eyes. Okay? Here we go. The tangent. Say again? Y over x. I'm doing a fraction here. What is the y coordinate of 270? -1. What's the x coordinate? -1 over 0 is, so we write undefined. So that means that at the tangent of 270 exists, it's undefined. It's going to make a lot more sense when we actually talk about the graphs of these trig functions. Okay? And if there's a 0 in the denominator, flashback, 0 in the denominator means there's what type of discontinuity?
Infinite.
Infinite. So that means on the graph of tangent, and don't worry, we'll get to those in due time, it's going to be an asymptote of 270. Oh, we were. We'll go back. Here we go. Cosecant of 11 pi over 6. Cosecant is 1 over y. So what is the y value of 11 pi over 6? So this is 1 over a -1/2. I cannot leave it like that. Multiply by the reciprocal, so it's going to be -2. So just remember, cosine is x, sine is y. Okay? Whiteboards. Yes. So we're back to our notes. All 6 trig functions are called periodic functions because they repeat their values at regular intervals. Okay? So for sine and cosine, every 2 pi radian, or every 360 degrees, their values are going to start to repeat. In other words, that means the ordered pairs are going to start to repeat each other after 360 degrees, okay? And tangent will start to repeat its values after every pi radian or after every 180 degrees, okay? And so if you look at your unit circle, everybody take a look at your unit circle, okay? And I'm hoping that everyone has written down this so I can flip back to my unit circle. Is my board? Yeah.
I didn't write it. Sorry.
Okay. All right, so we look back at our unit circle. Is it? There it is. Okay. So for your sine value, sine is what coordinate, x or y? Y. After every 360 degrees, after every 2 pi, you're going to start to repeat itself, okay? I'm just going to look at degrees because that's a little bit easier to see. I'm going to full 360 degrees, okay? If you notice, the pattern of your y's, okay? They're not going to start to repeat themselves until after they're going to full 360 degrees. After 360, what's the next angle measure? 390. What would this be?
405.
405. What would this be? 420. What would this be?
450.
Now these angles that are written in red, these are called what types of angles?
Coterminal.
Coterminal angles. So basically, 390 degrees, the sine of 390 degrees is the same sine as 30 degrees. Okay? They start to repeat each other every pi. Same thing with cosine. Cosine is x or y.
Coach Brown.
Cosine is what? X or y? X. Every 2 pi or every 360 degrees, those values, those coordinates are going to start repeat each other. So then the cosine of 405 degrees is the same thing as the cosine of 45 degrees. They're periodic functions. Tangents, they start to repeat each other every pi. So that means the tangent of 30 degrees is the same as the tangent of 210, which is the same as 390, which is the same as whatever value that is after that. Okay? Got that?
Wait, so they repeat instead of every what?
Every pi radian or 180 degrees.
I thought they repeated every 360.
That is only for sine and cosine.
So for tangent, it's every 180?
Every 180.
So-
Yep. Yes. Mm. Okay?
So we would see the same x or y values?
For tangent, you would see, tangent is y over x. So you would see the same combination for y over x for each of those. Okay? And it works for all the other ones, all right? So now you can find the sine, cosine, tangent, cosecant, whatever, of any angle. You just gotta find its coterminal angle, okay? So let's look at a few together. And then we're gonna do some of your whiteboards. Such as this one, okay? Cosine of 11 pi over 4. 11 pi over 4, that is more than 360 degrees. That's more than 2 pi radians, okay? Where is, what's the coterminal angle to 11 pi over 4? Let me see. How'd you get 3 pi over 4?
Because you can kind of do what you do with the mixed fraction, and so you would be able to take out 2 whole 2 pi's, and you'd be left with 3 pi over 4.
Okay?
Wait, what?
Let's I see what you're saying. Let's think about it. Coterminal angle. What was the formula for coterminal angles? It was theta plus
2 and pi.
2 n pi. So to get 11 pi over 4 is more than 2 pi.
What is the
N is any integer. So to find a coterminal angle, you would subtract 2 n pi. What value would you plug in for n to help you subtract? Or add, it's technically it's a plus, so what number would you plug in for n?
1.
Or a,
Negative 1.
so you would have 11 pi over 4 minus 2 pi. How can I subtract these?
Common denominator.
What's the common denominator?
4.
So 2 pi is the same thing as saying what over 4?
8.
And what's 11 pi minus 8 pi? So the cosine of 11 pi over 4 is the same thing as saying the cosine of 3 pi over 4. Cosine, is that x or y? So what's the x value of 3 pi over 4? Negative square root of 2 over 2. That's how you do those that are bigger than 2 pi, bigger than 360, or smaller than 0. Let's do B. The sine of negative 2 pi over 3. What's the coterminal angle to negative 2 pi over 3?
Negative 5 pi over 3.
Let's give me one that's in my unit circle. Yes, you are right. It would be negative 5 pi over 3. It won't be 0.
50 plus
Pi over 3. Add a 2 pi in there, guys. Negative 2 pi over 3 plus
4 pi. 6 pi, 4 pi. 4 pi over 3. Actually,
4 pi over 3. It'll be 4 pi over 3. 3. Sorry, not power of 3.
So wait, are we subtracting or adding?
When it's less than 0, we'll add. When it's bigger than 2 pi over 360, we'll
Less than
subtract.
0. So like negative numbers?
Mm-hmm.
So,
You add. When it's bigger, you subtract. Because think about it. Negative means you're going in a clockwise direction. Okay? You want some that are on the positive end, from 0 to 360 or from 0 to 2 pi.
So they're gonna like give us something like
That won't be on
be
your
so
circle.
far off that we'll have to like plug in 2 or 3 for it so we can get it back on.
Nothing too ridiculous. Nothing too ridiculous. What's the sign of 4 pi over 3? Say again. Negative 1/2. No, not negative 1/2.
Negative square root of 3 over 2.
Because sine is your y. And the y value of 4 pi over 3 is
Negative x.
tangent. Find the coterminal angle for 19 pi over 6. Bring it back. What's our coterminal angle?
7 pi over 6.
So the tangent of 19 pi over 6 is the same tangent as 7 pi over 6. Tangent is what over what?
Y over x.
Y over x. So the y value of 7 pi over 6 is negative 1/2. And we're going to divide that by the x value. And we're going to have to keep change flip. And we're going to have to what? What's rationalize? So what is our answer? So that is the tangent of 19 pi over 6. You have to rationalize because you'll have a fraction within a fraction. So you have to simplify that. That's where this part came from. When you multiply straight across, your 2's cancel out, leaving you with a positive 1 over a positive square root of 3. A negative times negative is a positive. Can't have a radical on the bottom, so again, you got to continue to simplify. A little long rule. Yes?
On the notes it said, it didn't say to it just said
Yes. Tangent. Tangent's only pi. So it starts to repeat every 180 degrees. So the tangent of yes, that is true. You guys gave me one extra one, but let me know for you, n could be any integer. So you could have plugged in 1 or you could have plugged in 2 and it still would have worked out. Now if you only did pi, you would have ended up with a number that still wasn't on your unit circle, so you would have to go an additional pi. Okay? So think about it. If I were to do subtract a 1 pi, right? I need a common denominator. What's my common denominator? 6. What's 19 pi minus 6 pi? Is this on your unit circle yet? So you have to do another pi to get one that is on your unit circle. And that's how we get that 7 pi over 6. So n could be any integer. It could be 1, it could be 2, it could be 3. We just need an integer that's going to get us on the unit circle.
Wait, so no matter what, as long as like you put minus pi, it'll get us to solve.
It will get you to your hope will get you to 1 that's on the unit circle. Sometimes it might be so big that you have to do multiple 2 pi's.
Teachers, please excuse me.
Say it again.
Why do you subtract instead of adding?
The reason why we subtract in this case is because 19 pi over 6 is larger than 2 pi. Like if we were to divide 19 by 6, that would be 3 and some change. So it's definitely bigger. So because it's bigger, we would subtract. If it was smaller than 0, say if it was a negative, then we would add either pi or 2 pi depending on the sine or cosine.
So if it's not on the unit circle, we subtract.
Or add, depending on if it's positive or negative. So we add it as a negative value, a negative angle, and we subtract it as a positive.
Sorry,
About 10 more minutes. Whiteboards, here we go.